This lesson is on conditional probability, which is defined as the measure of the probability of an event occurring given that another event has already occurred. Our first example deals with an ice cream shop. It sells ice cream to its customers. The options are chocolate or vanilla and cone or cup. The shop sells 250 ice creams in a day. They sold 170 cones and 150 chocolate ice creams. There were 70 vanilla cones sold in the day. Go ahead and make a two-way table and a tree diagram based off of the data displays lesson. In number 1, you're asked to circle the data above that shows the amount of cones sold in the day. Using a highlighter, the total number of cones sold in the day from the two-way table can be seen here as a total, 170 cones. In the tree diagram, the total number of cones would be found in the chocolate cones as well as the vanilla cones. Number 2, circle the data above that shows the amount of chocolate ice cream in their cones in a day. That would be the intersection of chocolate ice cream and cones, which can be found right here in the two-way table. In the tree diagram, from the total number of ice creams that we have sold, 150 of them are chocolate, and 100 of them would be the chocolate cones. Number 3, if you know someone got a cone, what is the probability that they ordered chocolate? Justify your reasoning. 3, if you know someone got a cone, what is the probability that they ordered chocolate? Justify your reasoning. This is an example of conditional probability. The condition, or the event that has already occurred, would be that this person got a cone. We no longer are looking at the entire 250 ice creams that were sold that day. Now we are looking at the 170 people who got a cone. And of the 170 who got a cone, 100 of them ordered chocolate. So the probability would be 10 out of 17. In words, we could write this as the probability of chocolate given cone. 4. Explain in words the probability of cone given chocolate and calculate that probability. The given condition, or the event that has already occurred, is that this person had ordered chocolate ice cream. Of the 150 people who ordered chocolate ice cream, the probability that the person got it on a cone would be 100 out of 150, which is 2/3. In words, it would be 5. Why are the results of the probability of cone given chocolate and probability of chocolate given cone different? The probabilities are different because the preceding event, or the given condition, was different. In the first example, the condition was that this person had ordered chocolate ice cream. In the second example, the given condition was that it was ordered on a cone. Example 1. An experiment was conducted to see how many men and women have the chickenpox. Of the 300 men, 50 had the chickenpox. Of the 200 women, 30 had chickenpox. Make a two-way table of the data. For example 6, find the probability of male given chickenpox. Interpret the result. The given condition is having the chickenpox. We have a total of 80 people who have the chickenpox. Of the 80 who have the chickenpox, what is the probability that the person chosen is male? Of those who have the chickenpox, 50 of them are men. Therefore, the probability of male given chickenpox would be 50 out of 80. Interpret the result. In number 8, find a conditional event that has a probability of 0.375. 0.375 is equivalent to 3/8. This example requires a little more critical thinking. We're trying to come up with a probability of 3/8 for a conditional event. So we are not trying to find man and chickenpox out of the total, nor are we trying to find how many people have chickenpox out of the total 500 people. So in order to come up with a conditional event, we're using the totals of each column or row. We can take a look at the table and see if we're able to come up with a probability of 3/8. We can play around with some of these examples. What is the probability of having chickenpox given you are male? Would be of the total 300 men that we have, 50 have the chickenpox, so this probability would be equal to 1/6. Please go ahead and work on numbers 7 through 10. Pause the video at this time, and when you are ready, go on to the next slide. Please go ahead and check your answers at this time for 7 through 10. Complete the two-way table and write 3 conditional statements from the data. Then make tree diagrams and show each conditional event. If the 2 genders we have are men and women, and 35 of them are women, then the remaining 30 must be men. We have 30 men in first period, 20 men in second period, so we have a total of 50 men in first and second period. We have 35 women in first period, 55 total women, which means that the remaining 20 must be in second period. Men plus women in second period give us 40 students total in second period. And between first and second period, we have 65 plus 40 students, which would equal 105 students. We also can confirm that the number of men plus women also equals 105. You can come up with any example that you want and your answers will vary. One possible conditional statement you can have is finding the probability of women given they are in second period. This conditional probability would be of the 40 total students in second period, 20 of them are women. So the probability would be equal to 1/2. Your tree diagrams can also vary. One possible tree diagram you can have is just looking at your entire second period class. Of your second period class, the 2 different genders we have are men and women. In your data displays lesson, you saw that you put the totals underneath each of the different categories. So for second period, we had 40 total students. Of the 40, 20 of them were men and 20 of them were women. And that is one way that you can create a tree diagram. Another way that you are able to write tree diagrams is writing in terms of a proportion. As a proportion, second period would be 1 because this represents 100% of the students in second period. Of the total, 20 out of 40, or 0.5, would be how many men are in second period. 20 out of 40, or 0.5, would represent the number of women in second period. Again, tree diagrams can sometimes be seen with totals to represent each of the categories, or they could be written as a proportion. Either way for all of the following examples are fine. Statement 2 and 3 are examples of possible solutions you can have. Please go ahead and complete the next example on your own. These are some examples that you can have for the conditional statements and the tree diagrams.